So today I'm going to show you how to create a virtual station using Robot Studio and all the tools it has to offer. The station that we're going to create today is going to not be able to be used as a real system mock-up. To do that, we will create other videos and tutorials to create a station that matches a real system. If you have your robot designed in this virtual station and the work object set up correctly, you can create programs and modify the code via templates or a text editor. This process is also good for reach studies, cycle times, and for creating part modules that can be edited later. For the sake of this argument, I'm going to create a robot cell with a welding torch and skyhook positioner, also called a tilt-turn system by other integrators. In this video, we're going to assume that you've already downloaded the arc welding power pack to your program files, as well as the robotware you want to use. The robotware can be found under the robot apps under the add-ins tab inside this program. As you can see to the right of the screen, you can see the robotware that's currently selected. We're going to be using robotware 6.10-01. To build the system, we're first going to go to the controller tab. Under the configuration group, I'm going to select the installation manager pick list. And since I'm using robotware 6.10.01, I'm going to select installation manager 6. As we open up installation manager 6, you'll see that it wants to pick from a list of controllers or create a new one. We're going to create a new controller, a new virtual controller, that I'm going to name Thane Test 1. And it's going to be a new controller. We aren't taking it from a backup. We're not pulling it from a virtual system. We're just creating the controller. Once we hit next, then it's going to go to the products tab, and we're supposed to add the products that we need to do to run this virtual controller. So to do this, we have a robot and a positioner. So what we have here is robotware, positioner, and motor and gear units. We need the robotware. We're going to use 6.10-01. So we'll add that one in. And then we're also going to add, since we have a skyhook positioner coming in, we also need to grab the positioner option. And then once we hit the next arrow on that, then it shows us the licenses we're using. Right now we're using the virtual free write license that ABB gives to us. So we hit the next arrow, and it comes up to the options. Now, when you're building a virtual controller, ABB gives a ton of options, not just for arc welding, but also for pick-and-place robots, conveyor robots, cobots. Anything that you want is available in their online libraries. So we're going to customize it to make our welding system. So once we do that, we want to first go to the options tab, and we're going to first select the default language, which it's already set on English, which works for me. And then we're going to go into the industrial networks tab. And when we go there, we want to go and select the first communications option with the device net master slave option. Once we do that, then we need to go into skip over all the other add-ins here, and we're going to go to motion performance. Oh, my bad. We're not going to motion performance. We'll go to motion events, and we're going to hit world zones. After we hit world zones, then we're going to go into motion functions. We're going to select path recovery and path offset. And we're also going to select from motion supervision a collision detection. Once we get that process done, I believe we're done with this page. We are. So next we're going to go into the drive modules tab, and we're going to first select the robot that we want. I'm going to actually not do the 140. We're actually going to pick a 2600 robot with a a 12 kilogram capacity and a 1.85 meter reach. Only reason I'm choosing this is I saw a robot system online that I would like to get one day, and this is to match what they had. Once we pick that option, then we're going to go and make sure that our drive systems are matching the 2600. It automatically selected for us, so we're good there. Our additional drive units, we want to make sure that when we're mating a robot to a positioner that we have additional drives for that external axis. So we're going to max out those external drive units or ADUs, because if you have a skyhook with a robot positioner and you wanted to manually jog that positioner, you need all 3 drives available. Also inside this application, we have what's called application ARC. The robot welding options are included in the drive module. For this application, we're not tied to any specific welder. We're just getting it to where we can run arc welding power pack and do some programming. So we're going to hit the ARC function. And since we don't have to choose a welder, we're going to use simulated welder. Now, if you're doing what nozzle searching and all that, and tracking and multipass and your welding options, then we need to select the weld guide, multipass, and the smart tech, and make sure those are all highlighted. If you had like a servo robot camera or some visual tracking system, then you would pick 660-1. But we won't have that on the system. We're just going for basic tactile sensing, weld replays, and weld tracking. Once we get done with that, we're going to go down and pick the positioner that we want. The positioner that we're going to select is an A-type positioner, which relates to the skyhook. I'm going to have a 750 kilogram capacity skyhook with a swing diameter, an effective diameter of 1450 millimeters. And when that comes up, it says to resolve the dependencies and make sure I selected the ADUs, which I did earlier, so I'm going to hit OK. And once we get done with that, we're going to be done in this drive module section. Once we get done with that, then we're going to go to applications. And I believe we're just going to make sure that we don't need anything else in here. Bullseye, if you wanted to set up your bullseye equipment, you could do that here. We don't really need that for just strictly part programming. If we had additional arc systems, we could throw those in. We're not going to do that. There's spot welding. We aren't doing any spot welding. It's just going to be gas metal arc welding or MIG welding. Weld timer options, that's more with spot welding. And then dispense and force control, we're not going to worry about that either. So from there, I believe we should be able to hit next, and it's going to give us a list of what we have going on here. Now, you would see that we have the 628 sensor interface. The only reason that that was added into the system is so that we could have the tactile sensing and the tracking available on our robot. So as you see here, we have a robot with a positioner. With our arc welding, we should be ready to go. So then once we do that, we hit apply. Hit yes on this installing the controller with my selections and installing those licenses since they're free. We're going to hit OK. And once that is done, we have our system made. This is just our virtual controller. It's not actually going to show up in the station yet. We need to start the virtual controller with this system that we made. So we're going to exit out of this. So now that we got that going, we're actually to start this controller. We're going to go to the Home tab. We're going to select the virtual controller drop-down box over the Build Station group. And we're going to hit existing controller since it's already created. We're going to select our system that we just created. Keep all these selections the same. We're going to hit OK. And it's going to be starting the virtual controller. As it's starting this controller up, it's going to ask us to select the equipment that we want to put in this virtual station since there was no existing libraries in this empty station. So when we select our positioner and our robot, we just have to make sure that we match what we put in our system file. So here it's asking us first to select our station. I want to make sure that we grab the right one here. It also gives us a height, which is just basically the height of the robot riser, which doesn't affect anything, it just affects in the physical realm. In the manufacturing, it doesn't actually go into the software. So what we need to select is, I'm going to select the tallest one here for just programming purposes. It has a 750 kilogram load, a diameter of 1,000. We want to do the 1450, and a height of 900. Once you do that, then you can see that our robot and our positioner are in our system. Our controller status is green, which means everything's good to go. Now we're going to reposition everything here. Once we do that, it's going to ask us if we want to update the controller or restart the system. We're going to do that at the end. So let me first place the robot and positioner how I want to. For the positioner, we're going to bring it up to 0, 0 on the task frame, where that location is, and then we're going to put the robot actually on top of the positioner. What's going to happen there in a real system is that you develop a robot riser that the robot would sit on that would be mounted to the floor. But to emulate it just in a virtual station, I'll just set it on top of the positioner without that riser. So we'll make sure we have the mechanism selected. And we're going to say we're going to position this bad boy, place it with 1 point. We're going to go from the base of the robot, make sure our points are selected here. Go from the base of the robot to 0, 0, and we only want to travel in the Z. So we got that guy selected. Now we're actually going to move the robot, and that's when it's going to try to tell us if we want to move the task frame. So I'm going to select it from the tree over here. We're going to say find the position. We're going to say place 1 point. And we're going to go from where it's currently at to the top of the plate of the positioner. And we're going to only do that in the Z direction. It's going to ask us, do we want to move our task frame? And for this cell, I'm going to say no. The reason was I want to keep the task frame and work object 0 at the base of the floor. It's easier to place equipment in a virtual setting and match it to the real system with everything when the 0, 0 reference is on some sort of floor reference. Oftentimes you'll find that some of the task frames are modified in other locations. Sometimes if you're doing a track motion or have a robot on a track, you would see that it's on the corner of a track or on some physical point of reference that's something different than the base of the robot, which is what we're going to do here. We're going to keep that task frame and work object 0 placed at the base of the positioner at the positioner center. So we're going to hit no here. Do you want to update the controller configuration and restart? No. The reason being is I'm going to reposition this robot again. I'm going to place it so that it's not hitting this positioner as it rotates around. So we're going to replace it again. We're going to move it again. We're going to bring the front of that robot, primary point from the farthest point out. Should be the front of that nose. We're going to move it to the front of that machined edge. And we're only going to go in the X direction. We're going to hit no again on moving the task frame. Hit no on this. So now we got the robot and positioner roughly where we want them. After we do that, we're going to make sure that our controller values and our station values match. The way you do that is you can go under the controller tab and go into the motion configuration under the virtual controller group. What you're going to want to do is we have two mechanisms here, robot 1 and station 1. You're going to select each of them. These are what the controller's values are stored at right now. So it's stored at 0, 0, 0, but our robot is actually up in the air and slightly off 0 in the X direction. So we're going to say we're going to use current station values. And we're going to say, okay. We don't want to restart the controller yet because we're going to do the positioner. So motion configuration, station 1, we're also going to use the current station values. We're going to say okay. Do you want to restart the controller? We're going to say yes. Now we're green on the motors running and everything's running as thought be. So I'm just going to come here, right click on the output and clear all that. So now we're going to actually try to put a torch on this system. There will be other torches you can use and bring in and create tools, and we'll have another segment video for that, but we're going to just use ABB's torches that they have existing in their libraries for simplicity's sake. So we're going to go under the Home tab, we're going to go Import Library, hover over the equipment, and then it gives us all this equipment, drive modules, cabinets, fences. We're going to go into the tools part of it, and I'm just going to select this 455 Binzel here. So now that torch is showing up at the base of the robot because it hasn't been attached to the robot yet. To attach this to the robot, we're going to simply drag it over the 2600 under the layout tree. And it's going to ask us if we want to update the position to put on the robot. We're going to say yes, and it automatically snaps it to axis 6 in the right orientation. So now we have a tool on the robot with a TCP. Now, all that work has been done by ABB so that it can happen that way. We'll go through the manual steps on how to define those in another video. So now we go to the positioner, and the one thing we need to do to the positioner is we need to create a user frame and a work object for this system. Most importantly, the user frame at this moment. The user frame defines the center of rotation on that platter. And that way we can establish coordinated motion between the robot and the positioner. And then we can teach that user frame on a real system so that the real system closely matches the virtual system to minimize error. So user frame is a definition of the center of rotation. And then we'll create an object frame, but that object frame will be in the same location as the user frame. The object frame is mainly used for tooling purposes. So if you were to put some tooling on this positioner with a part, a lot of times people have a flat machine surface with XYZ planar coordinate system defined by tooling pointers. And what would happen is when you got that fixture into your robot and secured in place in the headstock, then you would teach that object frame on the fixture itself. And once you set the parts in there, program your parts, and say you were to get a different part with a different fixture, you could unload that fixture, put in the new fixture, reteach a new work object for the second fixture. But if you ever came back to the first fixture and you wanted to program parts on that again, all you have to do is load that fixture back up, make sure the work object is correctly defined, and then you're set to go. You're not constantly reteaching from scratch, and it brings the points in really close on the real system. This also helps too if you have to decommission a robot and put it in another location. You aren't having to do major touch-ups on all your intermediate points. If you do the work right up front, all you'd have to do is reteach those work objects, and your parts should come in as they did in the old system. So let's show you how to create a coordinated work object. In a later video, we'll do some stationary work objects and go through this exercise again. But since we have a coordinated work object with a positioner, that's what we're going to be doing. So before we actually create the work object, we have to create a point of reference for the object to be on. The easiest way to do that is to use the existing frame on the positioner and create some geometry. So we're going to go to modeling. We're going to create a box. Doesn't matter what size it is. We're going to make sure our frame is selected here. We're going to make the corner point at the frame. We're going to just make a 20 millimeter by 20 millimeter box. After we create that box, then we're going to go and create our work object. Go into the other tab, create work object. We're going to name this object OB Station 1. This is going to be our coordinated work object for this positioner. And then once we create our name, our next selection is, does the robot hold the work object? We're going to say no, so that's false. Is it moved by a mechanical unit? Yes, it is. We're going to select the positioner that it's attached to. And programmed for external axes, you leave this argument as false. So now after we get the data in that we want, then we're going to go to the user frame and define that, and that's why we created this box. So we're going to do a frame by points and a 3-point method. So we're going to keep the same orientation of X, Y, and Z, so that visual there will kind of cue us onto how we want to define our work object. So the first point on our x-axis, we're actually going to go to the origin, do that. Our second point on the x-axis, we're just going to click on our other point that's on the x-axis created from our box. And then our y-axis, if we can get it selected here, is just going to be that third point that we based also off this geometry. We're going to hit accept on that. So we've defined the user frame, the object frame. We're going to do the same thing, 3-point, first point on the x-axis, second point on the x-axis, position on the y-axis, accept. The rest of this we don't have to change, and we hit create. And there we have our OB Station 1 user frame and object frame embedded in there. We're going to delete that geometry from that part. We don't need it anymore. And now we have a robot with a torch attached to it, a TCP, a positioner with an object frame. Now we're ready to load in geometry and start programming with this part, with this station.